Y'all be quiet. Let's get to it. Today we will do bow work, and then we're gonna do the handout from yesterday. We're working in chapter 3.7. All right. So this is a real world application problem, but it's still working with slope intercept form. All right. So this is a really common type word problem for slope intercept form. Um, It says write the equation for the total cost of oil. Graph the equation, state domain, and range. So I want to remind you that the number in the M spot is called slope. A lot of times it's also referred to as a rate of change. Um, Rate of change is the same as saying like cost per item, or the word each. Per and each refers to multiplication. Okay, so there's a lot of context clues in words that'll help you plug incorrectly to the slope intercept form. So bowling is going to cost you $4.50 every single game you play. So if you were going to make a table to figure out how much bowling costs, you would have to plug one in for X to figure out what one game is, two in to figure out two games, three to figure out three games. You would be multiplying this number times the number of games. Okay? Now, when you go bowling, do you have to re-rent your shoes every game you play?
Yes.
No, you don't. Your shoe rental is a one-time fee. Okay? So this B value, which is the y-intercept, is typically a one-time fee. Okay? So I wouldn't need to have any multiplication with the shoe rental. I wouldn't have to do 250 times 2 if I played two games. The multiplication comes into play with the per game. So the equation would be the cost, which is y, is 450 multiplied by the number of games. Maybe you want to put a multiplication not in there. Plus 250 for the shoes. So wherever it says per or each, you should know that means multiply. So that number has to go in as the slope. It is the rate of change because every game that cost is going to go up. The shoes is not the rate of change because you pay for the shoes once. Okay, so the answer to number one is y equals 4.5x plus 2.5. And x is the number of games you play or bowl. And y is your total cost. And you might think to yourself, I don't need an equation to do that. I don't need an equation to figure out how much it's going to cost me to go bowling. I just do 4.5 times 2. I'll get out my phone calculator. I'll add the shoes, and that's how I figure it out. But do you know who needs the equation? The software, the computer, the program has the equation in there. Okay? So we're not saying, oh yeah, whip out your calculator, write an equation to figure out how much it costs to bowl. But so you know, the way they made that computer work is with this equation. So this is the math behind the technology. Okay? Now we're going to make a graph. Okay. So X is the number of games that you bowl. So I'm going to label that. And Y is the total cost. Now I'm a little confused. How do I make a graph with 50 senses? What do you think, James? Right? No, I'm not gonna round for my graph, but I appreciate your input. That is a pretty decent idea, actually. Maybe we can round. I want to remind you about how to make a graph. So remember, when you go to graph, you're gonna begin on the y-axis. You begin at the b value. In this case, it would be 0, 2.5, and then you move the m value. M for movement, and that's rise over run. But that's kind of weird. There's a 0.5 involved. Kind of difficult. So we're not going to round it. We want to keep it accurate. What if we just do our y-axis by 50 cents? We'll do 0, 50 cents, $1, $1.50, $2, $2.50. Okay, let's try that. I'm going to make mine bigger, actually. Hopefully you can as well. Let's see. This will be it. The X. So 50 cents, 150. I need this from my character. We got 250, 350, 450, 550. I'm actually concerned it's not big enough. How much is one game going to be? It's going to be 450 plus 250. It's going to be 7. It's still not big enough. No, no taxes in this. I'm going to have to go to another. We'll make it bigger. Sorry, guys. There you go. So let's make it go up to, well, is it 25? I'm going to go even bigger. Hopefully you have room on your paper. I'm going to start over 0.5, 1.5, 2, 2.5, 3, 3.5, 4.55, 5.56, 6.57, 7.58, 8.59, 9.56. You guys have been doing a lot of graphing on Big Ideas Math, and it has a label for you. It's good to practice labeling it yourself as well. All right. For the x-axis, do we need to go by 0.5s? No. X represents the number of games. Do you pay for half a game in bowling? No. You don't. So for the x-axis, we can just go 1, 2, 3, 4, 5, because that's how many games you play. That was good. That was good insight. We're the only ones talking right now. Maybe I need to move you guys. All right. So it took me 3 tries, but I feel really good about the way my x and y axis is set up. I'm going to begin at 2.5, and then somehow I have to rise. So this is interesting. The slope is 4.5. If it's not a fraction, put it over 1. I'm going to go up. Riley, what's the rise going to be? And what's the run going to be? Good. Are you ready? You got your x and y set up? Did you apply your y-intercept? Let's do it. 2.5 is where we're starting. Even if we don't bowl any games, we're paying $2.50 for our shoe. So from here, I have to go up 4.5. I'd love to see you do it before me. I know how to count up 4.5 from here. I've got it all set up for you. You guys try it. I'm looking around. I'm not seeing a whole lot of x and y axes. I'm taking taking my time. I'm talking about it. I'm problem solving. Are you on board yet? Draw. Yeah, get on board. Draw a graph. Get on board. Let's try it. I do it just like that.
Miss, did I make it that big? Because I only made it before.
Well, I was talking about that. I decided to make mine bigger. You know why? What's the slope? Yeah. So if I'm starting at 2 and I gotta count up 4, I need to be over 6. That's why I have to see it from around. What about you? I'm gonna try graph. This is your chance on purpose. I'm slow. Talking about it. Problem solving out loud. Are you on board? Alright, so beginning at 2.5, I'm counting up 4.5. So I'm gonna try to count by 1. So this would be 1, 2, 3, 4.5 lands me at the number 7. So I'm gonna go up 4.5 over 1. My first game is gonna cost $7. That's 250 plus 450. I don't think I can do that. 1, 2, 3. So I'm just gonna go. And there's my graph. You get Genevieve? You make your graphs? I'd really love to see it like on a graphing calculator app. Maybe I'll even put it on there. Alright, so here's one game, and here's $7. 2 games will be $11.50. 3 games, I have to do 3. 11, 16 would be $17.50. And so on and so forth. Okay? Alright, let's go to number 3 and talk about domain and range. At one point, we did a handout, and I said domain and range is always all real numbers because the lines go on forever. They go on to infinity, positive infinity to negative infinity. But I said with word problems, it can be more complicated. That's all the handout said. It said word problems are more complicated for domain and range. So the reason is I actually had an endpoint here instead of making this go down as a line because you don't play negative bowling games. Okay? You also don't have a negative cost unless the bowling alley let you owe them money, which they don't. You pay a credit card, not bank money, but you don't typically owe a bowling alley money. So for the domain here, which again domain means X values, you can play 0 games, 1 game, 2 games, 3 games, and so on. Now, technically, do you think you're gonna play 1 million bowling games? That's really just a little question, doesn't it? All right, and your range is gonna go from $0 actually to 750, and 3 games we decided was 1750. So on. Okay. So the domain matches with the range. 0 games cost that much. 1 game costs that much. 2 games cost that much. So that was wanted to break down a good word problem with you guys. And now here comes the handout. I'm about to put in your quarter 2 handout grades that I already got. From last week.
That means I gotta get an 100 so I can have an A. I just put my pen away. It's not glued over. Miss, can I go wash this for you?
Alright, chapter 3.7. Transformations of linear functions. Who's got the extra?
She wants me to rip it off my hand. It's kind of working. Okay, good.
Anybody need one? Alright, this chapter 3.7 is a brand new concept. Wait, what?
Never mind.
Maybe you want to say move
She came in here.
Maybe you want to say move line. Alright, anyway.
Just put me right here. Bro, this is not going to be it looks so stupid. What would you trust me? Well, I'm not going to used to be this person who went back and brushed his teeth and did his hair and everything. He was lame.
Okay, no more conversation. Alright, what is a transformation? A transformation is a change, any change, in a graph size or location. And maybe some of you have heard this vocabulary before. Has anybody heard of a translation?
Yeah.
A vertical translation, does anybody know already what that means? What does it mean? Yes, really, really well said. That's a shift up and down. You shift the graph up and down. So what you're going to do is you're going to draw a line, like the bowling line, and you're going to move it up and down. A real life application of this is if the bowling alley increased their shoe price to $5. That would be vertical translation of 250. We would shift every single price up 250 if they increase the initial shoe cost to $5. That's a real life vertical translation. Horizontal translation. Does anybody want to guess what that one is? Uh-huh. Yes, shift horizontally. I like to say left, right. Horizontally is even better. So a horizontal translation will move it left, right. A reflection, you guys know, is a flip. If you flip across X, you flip the graph up or down. Reflection, that is mirrored over. A vertical stretch is like if your graph was like a rubber band and you were to pull it up, it would make it taller and skinnier. You may have heard this before called a scale factor, but a vertical stretch will it'll pull the graph up, making it more narrow. Yeah, like a scale. So the stretch vertically goes up, so it actually makes it skinnier, like pulling your rubber band up. It makes the slope more steep, really.
You gotta pick the top. Why? I can't do that.
And then the same way, you could pull a rubber band straight up, or you could, when you actually smush a rubber band down, it becomes wider. So a vertical shrink, pushing it down, actually makes a wider graph. I'm gonna actually expand upon this. A vertical stretch more narrow means steeper slope, and wider means flat slope. Is flatter a word? I think it should be more flat, but I better just do it right. I don't think flatter is a word, so I'm gonna say a more flat slope. Flatter. Well, you could like flatter somebody, like compliment them, as far as something being flatter, that's a flatter pancake. I don't know. I'm gonna go with more flat. Steeper. The hell is steeper than the other? I think steeper is the word.
I'm not gonna. No, I need to get this one.
All right. Skill number 1: understand vertical translation and function notation. A number, if the number is written after the f of x, it will shift the graph up or down. So this is like your whole clue here. And your book explains this really well too. So if you feel after this kind of lost, I do encourage you to read chapter 3.7 of your book. So if here we have a function f of x equals 3x plus 4. The f of x is the same as y. We're going to graph the f of x function. And then we're going to observe what's happening here and graph a new function according to this minus 7. So for number 1, this whole handout is all about practicing graphing. So we're going to begin at 4. We're going to make a graph. 1, 2, 3, 4. Put a dot there. And then we're going to do rise over run, which is the 3 here, of 3 over 1. So from 4, 1, 2, 3 over 1. 1, 2, 3 over 1. But remember, I said it's really much more sophisticated. You have to be able to do your slope the other way. I want to see a graph on both sides of this coordinate plane. We are. I'm going down right now. Try not to copy these points. Don't do that. Okay. What I would prefer you do is to look at your own paper. Know that you start at 4. Look at your own paper, count 4, put a dot, and then yourself go up 3 over 1. Try not to find my exact points and replicate it. Actually create the line for yourself, and just use mine as a check. It's too small. She can't figure out 4. It is pretty tiny. It's a lot of practice on one hand. So I'm gonna start up 4, but then my movement is up 3 over 1. Up 3 over 1. Start up 4, up 3 over 1. And then go the other way. Down 3, left 1. Make a whole line of a rise over run is 3, starting at the number 4. It's like 4 is the initial cost, and then it's increasing with I'm so glad. Alright, so that's old news, okay? That's supposed to be good to go. We're gonna make a new graph. The red one I'm gonna call f of x. You can label it f of x. It says we now are gonna graph a new one. This one's called g of x. And what g of x is the f of x graph moved down 7. I'm gonna write that with words. You just have to know it. What do you think, Logan? Nolan. I'd say Nolan, but I mean Logan too. So this means take your line and count every point down 7. So here, this one's at 4. From here, literally counting down 7 units. It's a vertical translation of -7. So I'm gonna go 1, 2, 3, 4, 5, 6, 7, and that's where I'm gonna put the dot. You count it down 7. It's a vertical translation down 7. And then I'm going to put this point, and I'm going to count that one down 7. 1, 2, 3, 4, 5, 6, 7, and put a dot there. Yeah. Start with your pencil on a dot that you made. Count down 7 and make a new dot. That's it. Making a whole new line, 7 down. You got it again.
Why would you say it like that? I forget. I'm still hungry. That's a joke. But yes, I'm still hungry. Wait, what kind of loss?
So the result is a parallel line. Okay, these lines are like train tracks. They're parallel. Let's try to graph one of these. Okay. Either F or G.
Well, I don't know more water to get. Okay, kind of weird. I have water.
Did you do a line? Do you have two lines or one line? You didn't. Are they parallel? They look like train tracks? Okay. So it when I really look at it, it kind of looks like it's down 3 or something. But if you focus on the y-axis, they should be 7 units apart. So this is the new one, the blue one you call G, because you can't call them both F. They're two different things. The original is F of X. The new one is called G of X. And what these symbols mean is that G of X is F of X down 7. So if you got it, you can try number 2. Start by graphing F of X, and then try to figure out what that number after it means.
I can watch my hands in 2 minutes. Oh, that's brother. Who's supposed to be next? That's like our last, I think. Hey, it kind of works. And that's kind of waterless. Let me see that. I feel like he can see it on his hair. I could see it on his hair. He goes superhero. You sound stupid. Leave me alone, bro. You've been doing. No, I'm actually really smart. I'm like Albert Einstein. So why don't you be yourself? Because I don't like doing that. I know it. Are you gonna go to college? Yes, okay. Morale. So you think you're gonna go to college? Well, I don't think. I know. You think? Yeah, because I got a scholarship already. To what? To what? MSA. MSA is not that great. I know. Yeah, my brother goes there. Huh? Yeah, my brother goes there.
Just 4 people starting number 2 in the right spot. That's good. Where should we start number 2? -1. So for this one,
Ish.
it's the second number, so it should be a y, an equal sign, a number with x, and another number. You always begin at that second number. You begin at the number that doesn't have the x.
She's right there. No. He's a red shirt. Okay. Okay. But when I was 215 and I started going.
From -1, what's the slope? And number 2, what's the rise over run?
That big.
Up 2 over 1. Yep, up 2 over 1. This paper has 2 purposes. It's to go back and review how to graph a line, and then also to talk about how to move a line.
That was you. It wasn't it stayed on the floor.
Okay. So I'm gonna go ahead and label that first line f of x. Now I'm gonna make a whole new line g of x. Nevaeh, how do you think g of x is gonna be different from f of x based on these symbols here?
It's gonna be smaller. No, it's gonna be the same but different.
So I'll go back to number 1.
Yep.
This -7 meant that we took the f of x and we moved it down 7. So what do we think the +6 is going to do? We're going to count it up 6. So our new line is just 6 units higher than our original line.
But on my way home, walking to the car, that you say you're gonna beat them up. They go looking for you and they jump you. I can take them on.
Actually, yeah, leave yourself. Don't go anywhere. Stand right here. Alright, so the +6 just means move every single point up 6. So originally I was at -1. I'm going to count up 6 from there and I'm going to draw this exact line. But it's up 6 from the original. No. Yeah, you start with one of these points and count 6. Because these symbols are like more complicated than a regular equation. This means take an existing line and count up 6 from that existing line. No, this one's called F, the new one's called G. G is F plus 6.
And I'm gonna find you some good teacher come after you.
You guys doing it again. You guys are toxic together.
People that are working and call people. I got an attention, the SOS signal. I want to find people with cars to come around. Okay. I dropped me a car, so I'm good.
Good job.
I can barely reach the pedal. One of those Walmart cars. But it's not and you're not going to get blinded. Yeah.
No more. You guys, yeah, but it's still out. So that's 2 people I had to talk to. You are not allowed to charge your phone at your desk. Okay? No charging phones at your desk. Okay. What was I gonna say? All right, let's move on to number 3. That'll be the last one we do today. The last one is you won't have homework. Just finish number 3. Everybody has to finish number 3. You don't have to finish it for homework, but right now let's finish number 3. So this is like -5 over 4x plus 0. There's no b here. It's like there's a plus 0. So I'm going to start at 0. And then I'm going to count down 5, right 4. And this is our first negative slope.
Teachers and students, pardon this interruption for a few brief afternoon announcements. There will be an Interact Club meeting in room 2113 at 2:30 tomorrow. Interact Club meeting in room 2113 at 2:30 tomorrow. There will be an ASID meeting this Thursday, October 24th, after school in room 102. Please join us for presentation on scholarship opportunities, refreshments, and some fun. All are welcome. Also, girls flag football meeting today, immediately after school, in room 9209. Also, everyone, today is Fields of Faith. Please come out and support Fields of Faith right on our baseball field from 5 p.m. to 7 p.m. Also, staff members, we will be having a homecoming trivia. So those teachers who like to skedaddle, as soon as the bell rings, you might want to hold on tight today and wait just a little bit till we make that announcement. Have a great day. I'm so sorry. The field of faith is 7 p.m. to 9 p.m. I greatly apologize. 7 p.m. to 9
Here's
p.m.
number 3.
Have
Should
a
be a
great day,
negative
and as
slope.
always,
Moved up it.
go Tigers!